Today we are going to do direction ratios and direction for signs. What are the direction for signs? If a straight line is in the space means x-axis, y-axis, and z-axis. There is a line. It's making an angle alpha with x-axis, beta with y-axis, and gamma with z-axis. Then cos alpha, cos beta, cos gamma are the DCs of the line, direction, signs of the line. What is the property of this? If we take the square of them, cos square alpha plus cos square beta plus cos square gamma, that should be equal to 1. What are the direction cosines? A line in the space making an angle x-axis with the, alpha with the x-axis, beta with the y-axis, gamma with the z-axis, then cos alpha, cos beta, cos gamma are the DCs, the direction cosines of the line, and cos square alpha, cos square beta plus cos square gamma should be equal to 1. And from here, one result can be 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square gamma. That is also equal to 1. 1, 1 cancel. So, what are you getting? 2 is equal to sine square alpha plus sine square beta plus sine square gamma. Right? This 2 will shift to another minus because this is minus, so we are shifting this to this side and here 2 is 1. The second result is coming from here. Cos square alpha is 1 plus cos 2 alpha by 2 plus 1 plus cos 2 beta by 2 plus 1 plus cos 2 gamma by 2. That is equal to 1. So we are getting from here this half, and this half will give you 3 by 2 plus half common cos 2 alpha by 2 plus cos 2 beta plus cos 2 gamma, that is equal to 1, or half is equal to cos 2 alpha plus cos 2 beta plus cos 2 gamma, that is equal to 1 minus 3 by 2, that is minus half. So what are you getting? Cos 2 alpha plus cos 2 beta plus cos 2 gamma is minus 1. Clear? So now first exercise start with the DRs and DCs. If cos alpha, cos beta, cos gamma are the DCs, we denote them by LMN. LMN. DCs of the line. A, B, C are the direction ratios. What do you mean by direction ratios? These are proportional to the direction. Means these are the multiples of, you can say, direction cosine. Here L square plus N square plus N square is equal to 1. But that is not applicable on DRs. DRs are just, if suppose you say, for example, because L square plus N square plus N square is 1. So if 0, 0, 1, 1 is the direction cosines, then you can say 0, 0, 3 are the direction ratios. Clear? Direction ratios are the multiples of this fractions of the direction cosine, we can see. Next, what are the direction cosines when 2 points are given? Suppose I have 2 points x1, y1, z1, x2, y2, z2. I have 2 points. Then DRs of these 2 points, DRs of the line between these 2 points are x2 minus x1, y2 minus y1, z2 minus z2. This bracket this crocodile mouth I am mentioning to denote the DCs or DRs, which is specifically written for DRs and DCs. Okay. So if I want to change, suppose this is A, this is B, this is C, DRs. And I want to change in DCs, so DCs will be A upon square root A square plus B square plus C square This we have done in vectors also. A square plus b square plus c square. C upon a square plus b square plus c square. These are the cases. Now come to the exercise. First question is, if a line makes cos 90, so in 90, 135 and 45 with x, y, and z axis. So what is cos 90? Alpha 90. Cos beta is 135. Cos gamma is cos 45, right? So this will be 0. This cos second quadrant, so it will be negative. So 1 by root 2 minus, and this will be 1 by root 2. These are the direction cosines of this line. Next, find the direction cosines of a line which makes equal angle with the coordinate axis. Means alpha is equal to beta is equal to gamma. So cos square alpha plus cos square beta plus cos square gamma will become cos square alpha plus cos square alpha plus cos square alpha, because beta and gamma are equal, is equal to 1. So you can say T cos square alpha is equal to 1, or cos square alpha is equal to 1 by 3, or cos alpha is equal to plus minus 1 by root 3. Clear? Next, if a line has direction ratios this, minus 18, 12, and minus 4, what are the direction cosines? So minus 18 upon 18 square, 324, 12 square, 144, 4 square, 16. Then 12 upon same, and minus 4 upon 7. So check what is value coming. 144 and 16, 160, 160, and 324. So that is 484. So that is, I think, 22 square. So this is coming 22 and 21. Right? Next, you have to show that the points are collinear. Here, no need to apply A, B, B, C is equal to AC. No need to do that. You will just find out the DRs of the line. So let A be the point 2, 3, 4. B be the point -1, -2, 1. C be the point 5, 8, 7. Right? Then DRs of AB by x2 minus x1. So -3, -2, -3, -5. See, this minus this, this minus this, this minus this. So -2, -3 will be -5. 1 minus 4 will be minus. DRs of BC. So that will be 5 minus minus plus 6, 8 minus minus plus. So this is 10, and 7 minus 1 is 6. So if you check the ratio, A1 by A2 is equal to B1 by B2, B1 by B2 is equal to C1 by C2. Isn't that equal to -1 by 2? So they are either collinear or parallel, but point B is common. Point B is common, therefore they are collinear. Clear? You can just show it by DRs. Same way you can find, if I want to change it into DCs, it divide by the square of sum of the square of the and square of it. This 9 plus 25 plus 9. So fifth question you can try by yourself. Take this as A, this as B, this as C. So find out DRs of AB, BC, and CA and divide by sum of squares and then take the square. Clear? Next is the equation of a line in space. Equation of a line in space for vector form, when one point is given and direction is given. And direction given. Direction means DRs are given. Then the equation is R is equal to A plus lambda B. A is point, B is direction ratios. So if I want to write it in the Cartesian form, it will be x minus x1 by A, y minus y1 by B, z minus z1 by C. Here x1, y1, z1 is this vector A, and A, B, C is this vector D. Clear? These are the DRs. A, B, C are the DRs of the line. So isn't it x, y, z is for R minus A is equal to, if I take this as lambda, so this will be lambda vector B. Clear? That's why R is equal to A plus lambda B in the vector form, and Cartesian form it is x minus x1 upon A, y minus y1 upon B, z minus z1 upon C, where A, B, C are the DRs and x1, y1, z1 is the point figure, position vector of a point figure. Next is, if direction ratios are now not given, but two points are given to us. Means x1, y1, z1 and x2, y2, z2. These 2 points are given to you. You need to find the equation. So it will be same only how the DRs come. X2 minus x1. So in place you will write x minus x1 upon x2 minus x1. Either write this way or find out the DRs and then write. X2 minus x1, y2 minus y1, z2 minus z1 is DRs. No? So either find first and then write, or directly find the one. So z2 minus z1. This is Cartesian form. So what will be vector form? R is equal to, this A is same. A. This will be lambda B minus A. No? Those 2 points difference. Clear? So this is for the 2 points. So now let us come to the exercise 11.2. Show that the 3 lines with direction cosines are mutually perpendicular. The condition for mutually perpendicular is A1, A2 plus B1, B2, C plus C1, C2 is equal to 0 for DRs, and L1, L2 plus M1, M2 plus N1, N2 for DCs. So now let us check whether they are perpendicular or not. Multiply them, DRs of the 3 lines. So first DRs are, DCs are. How do you know how to check the DCs? Square them and add them. You will get 1. So first line DCs are 12 by 13 minus 3 by 13 minus 4 by 13. Second line DCs are 4 by 13, 12 by 13 and 3 by 13. So if you multiply them, 12 fours are for A1, A2. This condition we are applying, or L1, L2, they are DCs. So these are DCs, so we are applying this condition. L1, L2. This is your L1, this is your L2. So 48 by 169 plus, this will be minus 3 and 12, minus 36 by 169. And this will be plus minus 12 upon 169. So if you add them, isn't it 48 minus 36 minus 12 upon 169. So this is 0 by 169. Isn't it 0? Other way also you can check. 4 into 3, 12. 12 into minus 4, 48 minus 48, and this is 36. So the same, it will be also 0. So you can show this by this one. L1, L2 plus M1, M2 plus N1, N2. And if DRs are given, then you will apply this one. A1, A2 plus B1, B2 plus C1, C2. For perpendicular, this is the condition, and for parallel, A1 by A2 should be equal to B1 by B2 is equal to C1 by C2. Clear? For parallel or for linear, you will apply these 2 conditions. So in the second question, it is show that the line is this. So let us take point A as 1 minus 1, 2, B as 3, 4 minus 2. This is perpendicular to the line through the point. So let us take it C 0, 3, 2, and D 3, 5, 6. So DRs of AB, x2 minus x1. This is 3 minus 1, 2. 4 minus minus, so it is plus 5 minus 2 minus 2 minus 2. DRs of CD, that is 3 minus 0, 3, 5 minus 3, 2, 6 minus 2, 4. So for checking the perpendicular, what will you write? A1, A2 plus B1, B2 plus C1, C2. This is A1, this is A2. This is B1, this is B2. This is C1, this is C2, right? So let us check. 2 into 3, 6. plus 10 minus 16. So isn't it 0? So lines are perpendicular. Here again find out the drs and check whether a1 by a2 is equal to b1 by b2 is equal to c1 by c2 because they are asking they are parallel. Okay. So what are the drs of if I take this as a, this as b, this as c, this as d? What are the drs of ab? Drs of ab. That is 2 minus 4. Minus 2, 3 minus 7, minus 4, 4 minus 8, minus 4. What are DRs of CD? 1 minus minus 1. So 2 minus 2 minus minus 2, 4, 5 minus 1. So if you just divide minus 2 by minus 2 is equal to minus 4 by 4 is equal to minus 4 by 4. Isn't it minus 1? So they are paired. Clear? Next, find the equation of the line which passes through the point and parallel to the vector. If their line is parallel to this vector, then their direction ratios are same in the same proportion. So can you take this as 3, 2 and this as lambda? So what will be the equation? R is equal to I plus 2j plus 3k plus lambda times because parallel is always multiply with some of the constant 3i plus 2j minus 2j, right? So this is the equation. Find the equation of the line vector. Cartesian form it will be x minus 1 by 3k, y minus 2 by 2k, z minus 3 by minus 2k. So you can take this as x minus 1 by 3, y minus 2 by 2, z minus 3 by minus 2 is equal to 2. Clear? Or that, whatever. Next, find the equation of the line in vector form and Cartesian form which passes through the grid and direction is this. So this is your drs and this is the point. So please try this question. Next, Cartesian equation of the line which passes through this point and parallel to this line. So these are the drs given. So what will be the equation? X minus minus 2 upon 3k because parallel is given. So take one constant over there. Then y minus 4 upon 5k is equal to z plus minus 5 upon 6. So that equation you will get x plus 2 by 3, y minus 4 by 5, z plus 5 by 6 is equal to 2. Clear? Next, write this equation in the vector form. X minus 5 by 3 is equal to y plus 4 by 7 is equal to z minus 6 by 2. Take this is equal to lambda. So x is equal to 3 lambda plus 5. Y is equal to 7 lambda minus 4. Z is equal to 2 lambda plus 6. So R is equal to A plus lambda b na. R is equal to X I plus YJ plus ZK na. So if I put this will be X is 3 lambda plus 5 I, then 7 lambda minus 4J, then 2 lambda plus 60. So if you combine this 5i minus 4j plus 6k, this is your A vector. Now take lambda common, so this is 3i plus 7j plus 2 plus 2k. Lambda terms you will collect this, and this. And earlier you have collected this point. So this is your A and this is your B. Clear? Next, find the angle between the following pairs of lines. Angle is always between their DRs. Always in drs. So cos theta is equal to V1 dot V2 upon magnitude of V1 V2. Okay. So what is V1 over here? That is 3i plus 2j plus 6k dot I plus 2j plus 2k. This is your V1, this is your V2 drs upon magnitude of this will be 9 plus 4 plus 36 and magnitude of this will be 1 plus 4 plus 3, right? So this is I dot I, j dot j and k dot k. So this is 3 plus 4 plus 12 upon 49 is 7 and 9 is 3. So this is 19 by 21. So theta is equal to cos inverse 19 by 21. Here, this is the angle between them. Next is, in this also, take this as B1, this as B2 and try the question. Clear? Now, here also, find the angle between the top, these two lines. So what is B1? These are the DRs of first line, these are the DRs of the second line. So B1 is 2i plus 5j minus 3k. B2 is minus I plus 8j plus 7j. So cos theta is B1 dot B2 upon magnitude V1 magnitude V2. So 2 I minus I is minus 2, 5 into 8, 40, 4 into minus 3, minus 12 upon. This is 4 plus 25 plus 9 and this is 1 plus 64 plus 60. So this is 40 minus 14, 26. This is 29 and 9, 29 and 9, 38. And this is 80, 70, 81. So that will be 26 by 9 into, sure this is 4 plus 5 plus 9. Yeah. So that is 13 and 38. So theta will be cos inverse of this. Yeah. Now, in this question, if you remember, when there is no point, this is the equation of the line passing through the origin. First one. This is the equation of the line passing through the origin. So if they ask you and they have given you 2 points in which one is origin, then it is compulsory for you to take that as a point. Suppose they have given find the equation of the line which passes through the origin at the point 1, 2, 3. One point is 0, 0, 0. Another point is 1, 2, 3. Then it is compulsory for you to write x minus 0 over here. That shows that the line passes through the origin. If you will take 1 point over here, then that doesn't mean that it is passing through the origin. Then need to check. Clear? So if the line is passing through the origin, so take this x minus 0 upon 1 minus 0. Y minus 0 upon 4 minus 0. Z minus 0 upon P minus 0. Right. X2 minus X1, Y2 minus Y1, Z2 minus Z1. So if there is no point in the numerator with the X, then that means it passes to the origin. The same way you can do this question. Now for question number 10, first you need to check whenever any question you are doing. In the previous question, it was already X, Y, Z, 1, 1, 1, 1. So I didn't mention that. Here if you see, this is 1 minus x by 3. 7y minus 14 by 2p. Z minus 3 by 2. And here it is 7 minus 7x by 3p. Y minus 5 by 1. Z 6 minus z by 5. So in this type of question, it's compulsory to make x, y, z as plus 1 coefficient. Here it is minus. So what will I do? I'll take minus 3 common. Here 7 common. And here z is 1 only. So same. So it will be x minus 1 by minus 3. Y minus 2 by 2p by 7. And z minus 3 by 2. This is your first equation. Now for the second, this is your first equation. Second equation will be minus 7 common. So it will be x minus 1 upon 3p. Here y is 1 only positive. So no need to change. And here minus of z minus 6 upon 5. So the equation will be x minus 1 upon minus 3p by 7. Y minus 5 upon 1. Z minus 6 upon minus 5. Here, compulsory to make x, y, z as one coefficient of x, y, z as plus 1. It can't be any other coefficient. Now, for right angle, the Diaz product will be, some of the Diaz product will be 0, means A1, A2, B1, B2, C1, C2. If we add them, then that should be 0. So, this into this plus this into this plus this into this should be 0. So, let us do that. Minus 3 into minus 3p by 7 plus 2p by 7 into 1 plus 2 into minus 5. That should be equal to 0. So find out 9p by 7 plus 2p by 7 minus 10 is equal to 0. So if you take the LCM, that will be 9p plus 2p, 11p by 7. That is equal to 10. So p is equal to 70 by 11. That is the value of p for which the two lines are at right angles to each other or orthogonal to each other or perpendicular to each other. Any word is written, you will do the same. This question is same, please try. Here the coefficient is 1, 1, 1, so no need to change over here. It is also 1, 1, 1, so no need to change over here. Just take these two ds and check A1, A2 plus B1, B2 plus C1, C2 is 0 or so. Clear? Now, next question is shortest distance between the lines. For this, you need to be clear that I can take two lines distance when they are skew lines. So you will be, if two lines are in the same plane, means if you draw the two lines on the same page, will not either they will be parallel or they will be intersecting somewhere on the same page, means they are in the same plane, right? But if you are you will draw two lines in the two different planes. One is in one copy and another is in one copy. So will they intersect? No, no, because both have the different planes. So those type of lines are called skew lines, and we find the shortest distance between them. These are skew lines. So what are skew lines? Two non-coplanar lines. First condition is they shouldn't be in the same plane. Two non-coplanar lines which are neither parallel nor intersecting. Neither parallel nor intersecting. Those lines are skew lines. So might be they can ask in the government, say, what are the skew lines? Show that these two are skew lines. Or they can give you the question, check whether they are intersecting or not. So this is for the skew lines, that type of question. What are the skew lines? Two non-coplanar lines. First condition is they should be non-coplanar. They shouldn't be in the same plane, because if I draw the two lines in the same plane, they will be either parallel or intersecting. So two non-coplanar lines which are neither parallel nor intersecting are skew lines. And we will find the shortest distance between the skew lines. And the formula for that is, first they will give you two lines R is equal to A1 plus lambda B1 and R is equal to A2 plus lambda B2. So if you need to find the shortest distance between them, then that distance will be equal to first, so it will distance is always positive, so we will take the absolute value. A2 minus A1 dot B1 cross B2 upon B1 cross B2 magnitude. So that cross product should be, if you, I think science students have done this in physics also, B1 cross B2 or any two this A cross B, then this is equal to I, J, K, A1, A2, A3, this is vector A, B1, B2, B3, this is vector B, right? Solve it like determinant. So this is the shortest distance between the two lines. This A2 minus A1 will give you ds, and this ds dot product with cross product of B1 and B2, which is the direct direction and divided by their magnitude. So first, let us check what is the question given to us. Find the question number 12. A1 is I plus 2j plus k. A2 is 2I minus j minus k. B1 is I minus j plus k. B2 is 2I plus j plus 2k. Right? So first A2 minus A1 vector, that is 2I minus I minus j minus 2j minus 3j minus k minus 2k. Right? So A2 minus A1 is one. Now let us find out B1 cross B2. So that will be I, J, K, 1 minus 1, 1, 2, 1, 2. Actually, we can find out by scalar triple product also A2 minus A1 dot B1 cross B2, but because we need in the denominator B1 cross B2 magnitude, so it's better to find out here only. Otherwise, you have to find it for the magnitude. So this is by determinant method I into minus 2 minus 1 minus 3 minus j into j, this is and this is one, so 2 minus 2 plus k into 1 minus minus plus, so 1 plus, so I am getting this as minus 3I plus 3j. This is your B1 cross B2. B1 cross B2 gives you a perpendicular vector which is perpendicular to both B1 and B2. Remember that. So B1 cross B2 magnitude is 9 plus 9, 18. So that is 3 root 2. Right now, 18 to the 9, sorry, 9 to the 18. So 3 square root has come out. So this is 3 root 2. So now we need to take the A2 minus A1 dot B1 cross B2. So that is, what is A2 minus A1? I minus 3j minus 2k dot minus 3I minus 3k. So this is, if I take the dot product, that will be I dot I. So minus 3, as j is not there in the second one, so j will be 0. and then -2 and -3 for k is +6. So this is coming 3, right? And this is 3 root 2. So what will be the shortest distance? Formula D is equal to A2 minus A1. What is A2 minus A1 coming? 3. A2 minus A1 dot B1 plus B2 is coming 3, and this is 3 root 2. Absolute value is also already positive, so this is 1 by root 2. Don't write the rational number in the denominator, so rationalize it. So this is root 2 by 2, so 1.414 by 2. So 0.707. You can write this. Here we have taken this minus, actually is plus. So this is -6. So this is -9, right? But we have to take the positive value. So if we are writing over here, that will be -9. So we will make it positive. So that is 3. So 3 by root 2, rationalize it. So this is 3 root 2 by 2 units. Distance is this much units, right? Here it was plus, but we had taken minus. So this is the distance. Next one is this is your A1, this is your A2, this is your B1, this is your B2. Now in this question, if they don't ask you the shortest distance, but they ask you whether these lines are intersecting or not, then this dot product will come 0. A2 minus A1 dot B1 cross B2 means they are lines are if this dot product comes 0 now, that means the lines are intersecting. Clear? It can be 2-mark question or 3-mark question. Check whether the lines are intersecting or not. So what will you do? Either you will find out for intersecting, you can directly take this way also. A2 minus A1 dot B1 cross B2 as first A1 minus A2 is 1 minus 3 minus 2, and then B1 is 1 minus 1 1, and B2 is 2 1 and 2. Solve this determinant, it should be 0 for intersecting lines. Clear? A2 minus A1 has come in the first row, B1 has come in the second row, sorry, and B2 has come in the third row. Now, so expand this with by determinant, this should be 0. Either show by this determinant or find out this A2 minus A1 dot B1 cross B2. Actually, what is used over here, that is scalar triple product. A dot B cross C. That is a determinant with 3 vectors that is used over here. So this A2 minus A1 dot B1 cross B2 now, so that A2 minus A1 will come over here as the first row, B1 as the second row, and B2 as the third row. And if you expand this and this is coming 0, then lines are intersecting. Otherwise, shortest distance is there. Clear? So independent question, if the show that the lines are intersecting, or check whether the lines are intersecting, then you can directly show it. Then question number 14. A1 is I plus 2j plus 3k. A2 is 4i plus 5j plus 6k. So A2 minus A1 will be 4 minus 1, 3i, 5 minus 2, 3j, 6 minus 3, 3k. This is your A2 minus A1. Then B1 is this I minus 3j plus 3j plus 2k, and B2 is 2I plus 3j plus k. So let us find out B1 cross B2. That is equal to I j k 1 minus 3 2 2 3 1. So this will be equal to I into minus 3 minus 6. So minus 9 minus j into 1 into 1 minus 4. So minus 3 plus k into 3 minus minus plus 6 to 9. Right? So that is minus 9i plus 3j plus 9k. This is your B1 cross B2. So what will be the magnitude of this? B1 cross B2, that is 81 plus 9 plus 81. So that is 90 plus 81, 171. That will be 181 and 81, 162, 162 plus 9, 171. No? So now find out A2 minus A1 dot B1 cross B2. A2 minus A1 dot B1 cross B2. That is 3I plus 3j plus 3k dot minus 9I plus 3j plus 9k. So that is equal to minus 27 plus 9 plus 27. So that is coming 9 only. So what is the distance? 9 upon square root 171. 171 is 19 nines, right? So that is 9 upon 9 square root will be 3 and 19. So this is 3 upon 19 square root. So you can write 3 square root 19 by 19. Better note to take the risk of writing the irrational number in the denominator. Always try to make it a rational number. Denominator we never put in that in the denominator. We never write the irrational number. Always be safer side to make it rationalized. Because if the marking scheme, this is the answer, then marks will be deducted. But if this is the answer, then it's okay. You are always on the safer side. So this is the way you can find out the shortest distance between two points. So last question you can try by yourself.